Not sure if I'm live. I expect so. So, first of all, hi everyone for being here and for giving me a little bit of time to talk about one big challenge that we face when working with AI, with large language models, and namely with synthetic data. So, today I'm going to explain a little bit of this, but first, let me just give you a little bit of context as to who I am and why am I here. My name is Hugo. I live in Lisbon, Portugal, and I'm one of the co-founders of Synthetic Users. So for the last 2 years, together with Kwame, we've been building this product that allows companies to do user and market research in a way that provides them value and can help them better understand their users and their customers. And while doing this, I've came across many challenges. And the main challenge is essentially that the biggest pain point right now in AI is evaluations, is figuring out if the outputs that we're getting from a system that uses AI and particularly large language models are good enough. Are they doing what we want them to do? So everything that we expect the system to do, it's doing it in a correct way. And evaluations, if we think about it in this kind of spectrum between art and science, I imagine some of you will be able to guess, but they fall right around here. It's a little bit of a mix between science and between art. And the reason for this is because there are so many tasks that nowadays large language models can help us with, and AI. So, from summarizing stuff to generating jokes to seeing if a content is relevant in terms of cultural sensitivity. So, there are now countless tasks, and the list that I'm sharing here is in no way complete. There are now countless tasks that we can use these large language models to help us. And all these tasks vary in one really important axis. How easy are they to evaluate? That's kind of what we're trying to understand a little bit here today, is how do we evaluate them? And it varies a lot. So if on the one side we have tasks that are really easy to evaluate, like for example, math. If we ask a large language model, what's the sum of 2 plus 2? And it answers 4, that's a verifiable question that we can easily understand if it's correct or not. Even if we ask it to generate code, we can run that code in a sandboxed environment and we can quickly understand if it's achieving what we want it to achieve. On the other side, we have stuff like, is this poem a creative one? That involves a level of subjectivity and nuance that it makes the task a lot harder. But there's one thing, if you, from my entire talk, you only take one thing away, is look at your data. There are a lot of ways to evaluate what these systems produce. There are a lot of ways to kind of check with different methods how well the outputs are, but nothing replaces on a regular basis looking at the data and trying to see it as a person and trying to look at that data from your perspective. So this is a really important thing, is looking at your data. Even when you use all kinds of evaluations, there's nothing like looking at that data. One slight detour. It's not really a detour because it's something that it's quite core to the discussion we're having, but we keep hearing about hallucinations. And hallucinations in a context of mental health or humans have quite a different meaning from what they have in the context of AI and large language models. So in the context of humans, an hallucination is perceiving something, seeing something, feeling something, hearing something that doesn't really exist. This can be for a lot of different reasons, mental health issues, or drugs, for example. But in the context of machine learning, it has a quite different and precise meaning. So it's when a model generates something that is plausible but not factually correct, or it's fabricated. And we've seen cases where this kind of has real impacts in the world. So lawyers that use ChatGPT to do legal briefs, and then ChatGPT hallucinates cases that never existed. But these are verifiable facts. So in these cases, it's quite easy. For tasks like generating a poem, there's no sense in which we can use the word hallucination, because hallucination can only, in the context of machine learning, can only exist in the context of verifiable data. So 2 plus 2 equals 4. It's something that it's verifiable. If a poem is creative or not, it's not verifiable. It depends on whoever is assessing that. So hallucinations have a really precise meaning on this. Most people discuss it as if it was more of an ambiguous thing, but it's not. It's only when it's verifiable. And evaluation is hard because the tasks, as I mentioned, vary in how easy they are to verify. As I mentioned, math, quite easy to verify, creative writing, not so much. But even for one task, it can be both. It can be both easy to verify and hard to verify. Let me talk about an example. So what you see here are 4 possible answers from a large language model based system working as a customer support. Let's imagine that someone reaches out to a company and says, hey, how can I update my credit card on your platform? And these 4 quadrants reflect 4 possible answers that vary in 2 criteria. On the vertical axis, we have the tone. So is the answer written in a tone that is adequate for this task? And on the horizontal axis, we have, is the information correct? Is the information that is being passed correct? So there's a mix. So same task can vary. On the top right, we have the best answer possible. So it's right in terms of tone, and it's also passing the correct information. Right below that, the information is correct, but that's not the tone we want our support system to talk to the customers. Then on the top left, the tone is correct, but the information is not really correct. And on the bottom, that's the worst one, of course. Neither the tone or the information provided are correct. And these are just 2 criteria. I could apply even more criteria to this. I could rate my answers in terms of fluency. So how easy are they to read and to understand? So that would add even more complexity to the evaluations. So it really depends on what you want to evaluate. You can evaluate on one single task, one single criteria. You can evaluate on 2. You can evaluate on many, many, many different ones. A real world example. So I told you I'm working together with Kwame building synthetic users. Synthetic users are essentially versions of customers or people that can be used to do user interviews. This is particularly helpful for the purposes of user and market research. Sometimes on the early stages of your research, you don't want to invest immediately in go talking to humans. You can use synthetic users. There are countless examples in which our product can provide value, but I'm here to tell you how I do translate the challenges of evaluating to our day-to-day. So if we think about synthetic users, we generate user interviews. To simplify it the most, this is not at all just how we think about it. There's a lot more nuance, but you can think about synthetic interviews, the quality of them, or how well they match humans in 2 axes. One is content, and the other one is form. By content, I mean, if I were to run the same interview with an equivalent human, would I get the same topics? Would I get the same emotions? Would I get the same pains, the same challenges, the same problems, the same needs, the same aspirations? And that is the content of the interview. And the other one is the form. Is this text that was generated in this interview exactly in the same way as a human would respond? And while in synthetic users, we aim to have the perfect content matching. The same doesn't really apply to the form. So the form, we don't want or synthetic users to answer in that kind of broken down discourse that we sometimes see in real user interviews, in human user interviews. So we optimize for one, but not for the other. So we do this on our own. There are also quite some academic papers right now that are essentially figuring out how well do large language models match humans at different tasks with particular characteristics and demographics. And the way we do it is we interview humans, we transcribe the scripts. We don't, but we have automated systems for that. Then we run the equivalent interviews with synthetic, and we calculate the parity between one and the other, focusing on the themes that come up, on the depth and specificity of the insights, comprehensiveness. So we have our own system to calculate this. So the most important thing that I want you to take from this part of the talk is that you need to decide on what criteria you want to use to evaluate the outputs of your systems. And this is highly context dependent. I would love to have a perfect answer to give you. This is what you need to do in your system, but it's highly context dependent. As I mentioned, for us, content is the most important thing, form not as much. So it really varies from system to system. So, and how then can we perform the evaluations for each of the criteria that we feel is relevant? Several different ones. So the first one is essentially automated metrics. These automated metrics are things that you can be running constantly. Just to give you a quick example of three of them, varying in kind of levels of nuance. One of them can be lexical similarity. So are the words mentioned in one by humans or said by humans the same that a synthetic system does? This is quite crude because it doesn't take into account synonyms. It doesn't take into account the nuances of language. Then you move into more embedding-based similarity, so semantic matching. So in this case, even if two sentences are not exactly the same in terms of syntax, as long as the topic and the sense and the meaning of them matches, these systems are already capable of understanding those matches. And for example, at synthetic users, we use topic extraction through bird topic to extract automatically topics from human interviews and synthetic interviews and do that comparison automatically. So these are automated metrics. We then move into metrics that are a lot more, can handle a lot more nuance and can be quite helpful when building these kind of systems, although they come at a cost. They're not easy to scale and they're a lot more expensive, because essentially what you do in these kind of metrics is you ask humans, you ask people, annotators and evaluators, you give them a task, you describe the task that they want to perform, and they will then perform it. And this task can be as simple as having a system generate answers to queries or generate poems, and then asking the human evaluators to rate them on a 1 to 5, 1 to 10 scale, 1 to 7 scale in different criteria. So typical criteria that you use for this kind of stuff is fluency. Is this text natural and correct? Coherence. So if a question is about topic A and the model responds about topic B, it's not a coherent one. So you can rate that. Relevance. So is the response appropriate? Completeness. Is it a full response or is it something lacking? Conciseness. This is quite an important one. So is the model just writing a huge amount of text just to say that you need to update your credit card on your payment page? And for other types of tasks, you can also have humans rate stuff like creativity or diversity. So this is where you ask humans to rate from 1 to 5 or 1 to 7 or whatever the scale you want, the answers of a model. Another type of human evaluation is what's called pairwise comparisons. So essentially, for the same question or for the same task, you have the model generate two different answers, and then you have the evaluators pick which one is the best. either the best or the more fluent. Again, we can use any criteria that we want, but essentially, instead of having people write one single output, you put two outputs for the same task side by side, and you ask for preferences. And finally, a lot more nuanced and a lot more effortful, we have open-ended feedback and error annotation. So for any produced text, you can ask the annotators or the evaluators to highlight where the errors are, which ones are they, or any inconsistency that might exist, any criteria that you want, honestly, or even add open-ended comments like these answers seem to me to be drifting away from what was the core proposed task, stuff like this. So you can use human evaluators for this. Now, one that is kind of becoming trendy, it's going to come after this one. This system evaluation is not necessarily gathering feedback of the particular task, but using feedback from your own system, user feedback to assess how well is the large language model helping you accomplish whatever you want. For example, going back to my example of customer support, you can see how if the person was able to accomplish the task that the model generated an answer to help to guide them. You can see if the person was satisfied with the interaction. So this kind of stuff you can also use to improve your system. Let's keep in mind that evaluations are essential because they allow you to improve your system, to see what it's falling short, and to see how you can make them better by either changing the prompts, by either changing the data that you include for context, so you can then figure out how to make your system better than it is. Last one, this is kind of the trendy one. I use this humorous image to illustrate, but it's essentially LLMs as judges. So going beyond having LLMs just generating and doing the task themselves, we now have been seeing a lot of people starting to use large language models as judges. So instead of having humans evaluate how good the answer is in those criteria that we mentioned, you can have models that are prompted or even sometimes fine-tuned to do the same task, but to do this at scale. So assessing how well does the answer generated match the original text. So LLMs as judges is a growing field, and it's a way to balance essentially the scalability that you need with the quality that you get from humans. Here on this, I'm going to share, of course, the presentation afterwards. Here you can see how these different methods compare according to various criteria. So essentially, scalability. Of course, automated metrics are the most scalable ones. Human evaluation, the less scalable ones, because availability, costs, and fatigue. Then cost, consistency, nuance, speed, and setup complexity. So all of these are things that you need to take into account when you design systems to evaluate your generations. And sometimes you might want, it's a really high stakes thing, you really want human evaluation. Sometimes it's a less important one, and you might get away with just using some kind of automated metrics. But it's up to you to decide the criteria you want to use and how to use it and to which parts of the system to apply it. So having said all of this, not sure if all of you know who he is, but François Chollet is a researcher that works at Google. He's an AI researcher, an amazing one. And he has these tweets that I found fascinating, because when sometimes these systems become so complex and there's so many interacting parts, sometimes just vibes, just kind of feeling if it makes sense or not, can be a perfectly valid evaluation strategy. To close, evaluation is hard, but not doing evaluations is even harder, because if you don't know where a system is failing or falling short, there's no way for you to improve it. And don't forget, look at your data.
Amazing. What a timing. Thanks, Hugo. Really fascinating. Looking forward to working with you again. To the audience, you can jump to the next talk by clicking on the button on the left about putting complex AI systems into production. See you.
See ya.